So this is my video on rational function. So first of all, let's try to see what a rational function is. So this is a rational functions. Different from the functions that we have done before, like we had linear, which is like 2x plus 5, and then you have quadratic, which had x squared plus 6x plus 3, and then we had polynomials, right? Like cubic powers, right? Okay, which have 3 or higher, and actually these two are also polynomials, linear and quadratic, but general polynomial is like higher than 2, right? Okay, any power. But if you notice, look at this, there is no x in the denominator, no polynomial in the denominator, right? I mean, so here, if you look at it, you'll have a situation where you have a kind of a polynomial in the top and polynomial in the bottom. So such a function is called a rational function. Now, if you look at the graph of this, actually, we will learn how to draw these graphs. It looks like this. So there are these things in this graph that are of interest. First of all, you will notice that around 1, the graph, as the graph approaches 1 from the right, it goes to infinity. When the graph approaches 1 from the left, it also goes to negative infinity. So there's a kind of a untouchable vertical line here, and we call it a vertical asymptote. And if you notice that the vertical asymptote is the place happens at 1, which is exactly the place where the denominator of this rational function becomes 0. There's also a horizontal asymptote, right? And what is that? That means when you make x become very large, gigantically large, go to infinity, you can see that the function is going towards a number. In this case, it's going towards 2, right? And then to the left also, right? When x goes to negative infinity, also it seems to go towards the same number, which is 2. And that is called, it's like a horizontal invisible line, untouchable horizontal line, okay? Untouchable at infinity, really, right? Okay, and an untouchable vertical line and an untouchable horizontal line at infinities, and that horizontal line is called a horizontal asymptote, and we will learn how to find this. Okay, so first of all, how to find the vertical asymptote? That's pretty easy. What you do is you take you factor any common factors out, right? And then you just take the denominator, and then so there are no common factors here. You take the denominator x minus 1 and set it equal to 0, and then you get x equals 1. That is the vertical asymptote. And how do you find, so like, for example, if you have rational functions like this, once again, you have rational function, we have polynomial at the top, we have polynomial at the top, and we have polynomial at the bottom, right? Okay. So what we do now is we factor the polynomial at the bottom because we want to find out where it is 0. So we factor that and set it equal to 0, right? And then we get x is equal to negative 2 and x is equal to negative 3. So we have two vertical asymptotes, right? And you can see that actually from this picture. You can see at uh, negative 3 there is an invisible vertical line, and at negative 2 also we have an invisible vertical line where the function goes to infinity. Okay, so the function goes to infinity before negative 2 and then comes out of infinity after that, and only to go back to infinity at negative 1 and then comes out of infinity. And we can see that it also has a horizontal asymptote, which is the x-axis now. So how do you find the horizontal asymptotes? Well, there are three situations, and then let's explain these three cases. Only one of them can happen. First of all, if the degree of the denominator is greater than the degree of the numerator, then the horizontal asymptote is the x-axis. So remember, if the bottom is bigger than the top, like in this case, the bottom is bigger, the degree of the bottom is 2, the degree of the top is 1, so the degree of the bottom is bigger, so then the horizontal asymptote is the x-axis. Well, if the degree of the denominator is less than the degree of the numerator, something like x squared plus 3 over x plus 1, say, the degree of the denominator is 1, which is less than the degree of the numerator, so there is no horizontal asymptote. There is a thing called the slanted asymptote. We will learn how to find a little later, but no horizontal asymptote, right? And then if the degree of the denominator is equal to the degree of the numerator, So for example, if you have something like uh, x squared plus 9 over say 3 minus 5x squared, right? Or put 10x squared, right? Okay. So 10x squared plus 9 over 3 minus 5x squared. So the degree of the numerator is 2. Degree of the denominator is also 2 because that's the highest power. So they're equal. And then what you do is you take the highest leading coefficient on top divided by the leading coefficient on bottom, and you get 10 over negative 5, which is 10 over negative 5, which is 2, negative 2, and with that is the horizontal asymptote, right? And so let's look at some examples, right? So let's take a look at this one. Now here the degrees are the same, 2 and 2. So the horizontal asymptote will be what? The line, okay, y equals, you look at the coefficient on top, which is what? 2, and you look at the coefficient on bottom, which is what? The leading coefficient. Leading coefficient is 2, equal what is 1, so you get 2 over 1. So y equals 2, okay? And you can kind of see that in the graph. If you look at this graph, right, y equals 2 is the horizontal asymptote, okay? Take, take a look at this one. Now we have a bigger bottom than the top. The degree of the bottom is 2, degree of the top is 1. And in that case, we know that the horizontal asymptote is the x-axis. So we can see that from the diagram also. It's x-axis, right? And the third one, you can see that, the x-axis. Third one is when the degree of the bottom is lower than the top. The degree of the top is 2, right? And the bottom of the is 1. So 1 is less than 2. And then right, there is no horizontal asymptote. And you can see that from this, right? There's no horizontal asymptote, but there's a thing called a slant asymptote. So you can see there's a slant. So at infinity, it goes to as x goes to infinity, right? And x goes to negative infinity. The graph is not approaching a horizontal line, but it's actually approaching a slant line, which is called a slant asymptote. So lastly, we will find how to find the domain of a rational function. Well, you know that if you take this rational function, you can plug in any value. Domain, remember, is the valid inputs, right? Domain means valid x. And the only x's which are not valid in when the denominator becomes 0. So just like when you find the vertical asymptotes, you take the denominator and set it equal to 0. So and then you factor that, you get 2 and negative 2. So we'll have to remove those, right? Because they are not legal to be in the denominator. So what you do is all real numbers except plus or minus 2. And that's it for this video. Thank you for watching.